Welcome viewers to the SD online classes. Today we are doing class 10 physics chapter 2 MBSC. The human eye and the colorful world is the name of the chapter. Page number will be 61 in your MBSC textbook. The topic is scattering of light. We have done refraction, we have done atmospheric refraction, and we have done dispersion also. Now it is scattering of light. Almost similar to understand. On a sunny day you have seen the sky looks blue. Very common. During sunset it looks red, but actually you know the color of the sky is no color at all. It is totally dark. Okay, just like in space, you must have seen in movies also. They show the colors totally dark. Okay, there is no color in the space. Okay, the sky has no color. So we see these colors due to scattering of light. That means the light is thrown here and there, scattered, and that is called scattering of light. This phenomenon is called Tyndall effect. Okay, the phenomenon of scattering of light by particles, colloidal particles, is called Tyndall effect. So that we'll write. So this is called the phenomenon of scattering of light. Phenomenon is the process. Scattering of light by colloidal particles. Okay, this is called Tyndall effect. Tyndall is the person whose name, and because of his name he has given the Tyndall effect as the, because of the dust particle, all this you can see in the dark room. If you pass some light, you will find that in the path of the light many dust are seen. So that is called scattering of, that is the dust are scattering the light and you are able to see the scattered light. Okay, so this way you will see the example that prove that there is the scattering of light is there, right? Now we will try to explain what is the blue color of sky. Blue color of the sky. Now let us try to understand the color of the sky. You already know that there are 7 colors, V, I, B, G, Y, R, and this side you see violet, indigo, blue. These are blue type of colors. Okay, this side it is yellow, these are red, orange type of colors. So you see this side is less wavelength. Can you understand? Less wavelength. This high wavelength. In the less wavelength, now in the atmospheric molecules which are going to scatter, those atmospheric molecules, dust particles, whatever it is, if they are going to disturb this light, they will disturb this part more. This part they will not disturb more. So blue light will be visible. Blue light will be scattered, means thrown here and there, everywhere in the atmosphere, in the sky. So that is why you will not see this side, yellow, blue, the yellow, orange or red, this type, orange or red mainly, these colors you will not see, but you will see the bluish type of color more. This bluish type is more means because it has less wavelength. So the smaller molecules of the air are responsible. Okay, the atmospheric molecules of air which have sizes smaller than visible, right? So they are responsible to scatter the blue light more. So blue lights are scattered more, and then you will see the color of the sky is blue. Okay, very simple. So this way it is explained, right? So you have to study and you have to know the differences between all the other phenomena also. Okay. Now this application is also important. The color of the sun at sunrise and sunset, they are red. Why it is so? Let's explain. Suppose this is earth and this is above the earth, this is the air, atmosphere. Okay, when in the daytime the earth, the white light is coming from here and it has to pass only up to this height. That means the thickness of the atmosphere is not very high. So blue lights are less scattered. So you will see blue light all around here. Fine, understood. But in the sunset time or in the sunrise time, morning and the evening time, the light will come from here and it will have to travel a longer distance here. That means it has to pass a longer length. The atmospheric length is more here. So what will happen then? It will easily scatter the blue. It will easily scatter the blue because blue has less wavelength. Wavelength means less stronger in getting here and there. So it gets scattered by the particles. Here the particles are going to scatter them away, and then you will only see the red colors which are less scattered. Okay, very important. Red colors of the sky are less scattered because they are high wavelength and are scattered less, and that we will see that will travel to the earth and it will reach to us. Understand? During the daytime, the blue are scattered less. They are scattered but less. Why this is less? It has to travel the atmosphere path little shorter. Here the atmospheric path is longer. During that time the blue will be finished up, just like that, okay, finished up, because it will be used up too much, and but only remaining is red color, the strong color, which is strong means the high wavelength, and it will reach here. And this is the same reason we will use the other application also that we will write next. Okay, if I think you have understood this, you can see other YouTube videos also to understand this with the diagram, and easy to understand. Okay, this part, red light is used in danger signals also. This is also one of the application of scattering. Why? Let us see. Higher wavelength of the red light, red color. So that is why red color scatters less. Wavelength is high means the atmosphere will not be able to scatter it more. So you can see the visible color from with the red color from a far more place, visible at too large distance also. From very far you can see red color and you can be alert that some danger signal is there. Also, the red color is scattered least by fog and smoke. Even in the headlights also you use. Have you seen that the red color is used, or not the blue type, the red or the yellow colors type are used, because the red colors are scattered least by the fog and the smoke. Okay, so this is the reason red light is used in danger signal. All are interconnected. You can compare one with the other. Whenever you are studying new application, go to the previous one also and try to reconfirm whether what you are understanding is correct or not. This next application is also related to the previous one. Yellow color headlight in foggy weather. You have seen in the vehicles they use extra light, particularly in the sumos and the those which travel in the night. They are traveling in the foggy season, winter season maybe. Like that, during that time they will use the yellow color headlight. In foggy weather what happens? Okay, foggy weather what happens? Scattering of light is more. Why? Because there are more air particles. As the yellow color has higher wavelength. That's the reason. Okay, why? Yellow color has higher wavelength. How do you know it is higher? Because VIBGYOR. You see, yellow is on this side, more side. Okay, so that is why higher wavelength has yellow. So it scatters less. So its light coming out of the vehicle will be going here and there very less, and it will go directly, and it is visible from long distance. So that is very important in a vehicle to use. So that is why yellow color is used. Now white color of the cloud. What is the reason of white color of the cloud? That we will do the last one. Now the last one is white color of the cloud. Why the cloud? In the sky you see the sky is blue. In the evening time, in the morning time you will see red color, the yellow color, this, that, everything. But one thing is very common. You see in the daytime, you see the cloud, you will see is white. Why the cloud is? Because clouds are at lower height. It is not very far. Okay, clouds are not very far, and at lower height, such lower height, if it is not very far, air particles are relatively bigger in size. There the air molecules in the air, the molecules of the air particles are slightly bigger. Why they are bigger? Because it contains dust, it contains water droplets. In the cloud, of course, water droplet will be there. So these are bigger in the atmosphere. So when they are bigger, they will not choose which wavelength, this side or this side, they will not choose. If they are bigger, they will scatter everything equally. Okay, they will scatter everything equally. If they scatter everything, what is this everything? Everything is white color. So all the color of the light, that is white light, are scattered. Okay, all the colors. So we see all the scattered color. All the scattered color means we are seeing, what we are observing is white color of the cloud. So this is the reason for this. So we have completed this chapter doing all the explanation. Now your job is to study the textbook again and understanding the question answers. You can see quick recaps also in page number 63 it is given. Okay, good luck. Thanks.